Alright, so this is a 2-slide presentation today. Alright, so take your own notes on this. So a lot of the time, we will see functions presented like this, okay, where we define some function to be the integral of another function starting at some value and ending at x.
What is this called?
Integrals is a function of x. So what this function is saying, actually, I wanted to define this from -5 to 5, not -3 to 5. What this function is saying is we're going to take some function of h and define that to be the area under this graph, starting at -3 and ending at whatever value we want. Right? Okay. So if for these first few questions, okay, it says find h of -3. What that means is I'm going to plug -3 in for x. So if my x is here, okay, my x is part of this integral. So h of -3 means I'm going to evaluate the integral from -3 to 3 of this function. Right? So I guess I should have used a different variable there. Right, yeah. We're not going to accumulate any area if I'm starting and ending at the same spot. So the answer to this first one, h of -3, is just 0. And we're going to look, we're going to look at a lot of different questions with this graph. But, this is the function. We're going to then look at like mins, maxes, concavity, stuff like that with this graph. But for now, we're just plugging in values. Okay. The next one says find h of -5. So I'm plugging -5 up here. Okay. So that means find the area from -3 to -5. We'll say that is at -1 there. So, first of all, is this area going to be positive or negative? Nope. It's positive because I'm going backwards. Right? It's like a double negative. Right? We could change this, right, and say this is the same as the opposite of the area from -5 to -3 of this function. So then I would have negative area. Then, how would I find what this area is? Yes, this is just a triangle with a base of 2 and a height of 1. So what is that area? 1. Yeah, 1/2 times 2 times 1. So you guys try the next couple here. Okay, find h of 0, h of 1, h of 5. Wait, say that again. Well, we're not going backwards, right? Because we're starting at -3.
Oh, okay.
I'm starting at -3 and ending at 0.
-2, I would do it to that one. Is that a half?
Yeah, we can call that a half. 3 1/2, so 7 halves. Yeah, so this means area under the curve.
I was very I really can't do this if I'm not like drawing on it.
Sketch that. Or you can come up to the board and draw.
I'll do it for you.
The graph.
Which one are you on? Which one are you on? I don't know. We're just finding areas so it's just going to be half. What do you actually need to
For each of 0.
I just wanted to talk about
I believe that you can find the area of 3 triangles. So this would be so. Yeah, actually.
I was in so, in English, trying to make sure I got my work. And then,
Oh, she got this one.
I guess I didn't have it. Nice.
done.
Oh,
Alright.
so this happens.
That's
why did you have to make this up?
it's not that bad. It's 5. It's 8 minus 7. Hope that's right. Did that quickly in my head?
Oh,
Problem.
oh.
Yeah. It's actually 2 previous AP questions. Just stuff like this.
Now we have to take
Nope, it's not going to be. Alright, I did these quickly in my head, so hopefully they're right. Is that what you guys got? It's fine. Not always.
You did put a 1 half instead of a 1.
I did put a 1/2 instead of 1/4.
That's 7.
Which one are you looking at?
You got
that little tiny triangle.
You got me sick and you got Chris sick.
You haven't seen me in 4 days. How did I get sick?
You had the bug
Well, to
before you
find the area, it
left.
doesn't have to be right. Right? We're just taking the height times the
I
base.
just have a head cold.
So the height's
and
1,
infection.
base is 1.5.
Yeah, me too. Not a right triangle.
Infection,
It doesn't work
doctor.
2.
But
Okay.
headaches is a
No, headaches are not.
So any questions on these first couple?
Yeah.
All right. Then the next 4 say find h prime of some value. Well, we're defining h to be the integral of f of x. So h prime, if I take the derivative of an integral, those are inverse operations. Right? We talked about that with the fundamental theorem of calculus. So the derivative of an integral would just be this function, right? So h prime of -3 is actually the same thing as f of -3, right? Which we can see from the graph that y value at -3 is 0. 2, yeah. So h prime of 0 would be the same as f of 0, which is 2. H prime of 1 would be the same as f of 1, which looks like it's about 1. And h prime of 5 would be the same as f of 5, which is 4. Okay. You okay with that idea? Alright. Then let's take a look at mins and maxes and concavity and stuff like this.
I thought you were by working out with this.
This
Not like the past 5 minutes.
No, past 5 minutes. Okay, but this is all stuff that we've already done. Okay, it's just being applied now to a slightly different type of problem. Okay, and it's not really a different type of problem. It's just the directions are worded a little bit differently. It's still the same problem. So it says find all relative mins and maxes of h of x. In the context that we've done this before, we've said, here's a graph of the derivative. Give me information about the original function. That's still exactly what's happening. We're saying if h of x is the integral of this, that's still the exact same thing. We're saying this is the derivative of h of x. So if this is my derivative graph, how would I find mins and maxes of my original function? Yeah, we want to find the values where it crosses the x-axis and put those on a sign chart. So that happens at 3 places, right? Here, here, and here. So I'll make my sign chart for f and put -3, +2, and 7/2 on there. So what do I do with this sign chart then? Put some signs on it. So what does that mean?
There's a max at 2.
Right. Mins at -3 and 7/2, and a max at 2. So now, find the value of x at which h of x achieves its minimum value. Here we need to think a little bit about accumulating area under this curve. Okay? So if we're starting at -3, okay, and I go in this direction, the further I go, up until I get to x equals 2, I'm accumulating positive area. So the value of h is going to be increasing until I get to here. Right? Well, then I start accumulating negative area. So the value of h will go down until I get to here. And then I start accumulating positive area again. So this is all positive, right? This is a fairly large positive area. Then here we accumulate a little bit of negative area. And then here we accumulate a lot more positive area, right? So we're trying to find where h, which is the function that describes the accumulation of the area under this curve, achieves its minimum value. Where will I have the smallest area under the curve? at -3, right? It never goes below 0 once I get past -3. So I'm accumulating a fairly large amount of positive area and a little bit of negative area. So by the time I get to here, I'm still going to have a positive net area, right? And then I just add more positive area on. So the area under the curve never goes negative, okay? Or the accumulation of the area never goes negative. So what that means is the minimum value occurs where there is no area, right? Here at -3. So this one would be x equals -3. Now, it certainly would be possible for somewhere along the curve we would accumulate more negative area than positive area. Then we would have a minimum value there. But in this case, that doesn't happen, right? Starting here, we would only have a positive net area going forward. Next then, where would I achieve my maximum value? At 5. Right, yeah, because the same reasons that we just talked about, where we continue accumulating positive area. Right? Then, let's talk about inflection and concavity. So, the next one is find the x-coordinate of each point of inflection. Again, this isn't new. We've already talked about stuff like this. But how do I do that if I'm given the graph of a derivative? Yeah. So we want to look at values where the slope is either negative or undefined. So that happens with 0 and 3. So what do I do with those values? Those on the sign chart. So here we're talking about the slope of this graph. So to the left of 0 is positive. Right. So what does this mean? So yeah, so to answer this question, we have points of inflection at both 0 and 3 because I changed concavity at those values. Then we can also use this sign chart to answer the last question, on what intervals is the graph of h concave up? Right. -5 to 0 and 3 to 5. Because remember, this graph only goes from -5 to 5, and not from -infinity to 0, from -5 to 0. So make sure, especially on a free response question, you're checking bounds given in the problem, and incorporating that into your answer. Okay. Questions? All right, that is it.